let us discuss about exception and the types of exception as well as the vector table in this video. Okay, so first of all, what is exception? Exception is any kind of condition which needs to halt the normal sequential execution of the instructions. So this is what the definition of an exception is. It is any condition, it could be any condition. What are those conditions? Say for example, actually if ARM core is reset, okay, if you press the reset button and the ARM core is reset, that is a condition actually which halts the normal execution of the instructions. The normal program, okay, you have written a program, you are doing some work, the processor is doing some work, at that time actually the exception is raised. Okay, there are, of course, we call certain times the interrupt and exception. Both are like exception is something actually which is raised by the processor itself. Interrupt is something actually which is raised by an external event. We shall look into the interrupts later. Now any condition that halts the normal sequential execution of the instructions. A processor is executing certain set of instructions. At that time, due to certain conditions, the processor is interrupted. Okay, in a sense the processor, it halts the normal sequential execution of the instructions. Then it wants to answer this whatever the exception has been raised. What are those conditions? One, it could be ARM core could be reset, or something instruction fetch or the memory access feeds. Any of the like you have a memory, because the instruction is stored in the memory. At that time when the instruction is stored in the memory, you got to go and access the instruction. So instruction fetch can result, okay, or the instruction fetch whatever that is stored in memory, or the data access, the data fetch could actually result in the failure. At that time actually you have to handle this kind of exceptions. Maybe in the C program also you handle the exceptions, right? Whenever actually you try to divide by 0, okay, any number you try to divide by 0, that is actually infinity. Mathematically you say infinity, but that is not defined. So those kind of exceptions, that also you write a program to handle those exceptions. Similarly here also in our ARM processor, the processor has to handle certain conditions which will disturb the execution of the instructions. How do you handle those conditions? That is what we shall look into it. So what are those conditions? First we shall see. Now undefined instruction is encountered. Some undefined instruction, something which is not understood by the processor, that time we say undefined instruction. Or something software interrupt instruction is executed. This is like what you have SWI, software interrupt instruction. Software interrupt instruction is within the program itself. Programmer itself writes this software interrupt instruction for certain action to be done. Okay, so if that software interrupt instruction is executed, at that time how you want to progress with the handling the exception. Okay, so any of the external interrupt has been raised. Of course this external interrupt is what we call the interrupt itself. Interrupt is a special type of exception. Not to get confused in this one, interrupt is definitely a special type of exception. Okay, so interrupt is definitely a special type of exception. Say whenever ARM core, it could be any of the other conditions also. So I have listed some 5 conditions here. So this, when ARM core is reset, or some instruction fetch or the data fetch from the memory results in the failure, some undefined instruction which is not defined in the instruction set. Okay, you wrongly actually define an instruction. So that time actually software interrupt instruction is executed, that is SWI, or some external interrupt has been raised. External interrupt, in a sense, what you have like 2 kinds of external interrupts, maybe the IRQ as well as FIQ. We can include also reset button also. It is also one kind of interrupts. Okay, so these 3 kinds of external interrupts whenever it is raised here. So these are all like how do you handle these kind of conditions, because you can't actually keep on continuing with the normal execution of the instructions. You have to go back and answer these kind of exceptions also. Of course this is not an exception, these are the conditions which results in handling the exceptions. Okay, so that's why any of the most exceptions whatever we write it, they always have an associated software exception handler. Handler is something which handles the exceptions. Exception is a condition which halts the normal sequential execution of the instructions. Exception handler means the handler which handles this exception. What you write in the program to handle the exception in the C program, like if you want to divide by 0, you throw an exception and you try to not disturb the normal execution of the instructions. Okay, here in this case what we do, whenever any condition which happens which disturbs the normal flow of the execution of the instructions, at that time actually exception handler will handle the exception. What about the different types of exception? We shall look into those exceptions, different types of exceptions later on, but what handles the exception, we call that one as exception handler. Okay, so exception handler means a software routine, you just write the program. Okay, a software routine that executes whenever exception occurs. Correspondingly, different handlers you have to handle the different types of exceptions. So for example, I have written here a data abort exception will have a data abort handler. Okay, so the handler first determines the cause of the exception, then services the exception. Of course, whenever what happened in the because whenever some problem is there, then only it has the condition means is a problem. So that actually has resulted in the halting of the execution of the instruction. So software handler determines what has caused that exception. So software handler determines what has caused that exception, then services that exception. Okay, so of course servicing results in branching and all those things that we shall look into it later on. But one thing what you have to understand from this slide is that, so basically what exception is any condition which halts the normal sequential execution of the instructions. It's like an interrupt. So you are studying for the examination, you get a call, and then the call is a of course it's an interrupt. Okay, it's an external interrupt that you have. Maybe for example IRQ, something you will decide that now, so whether it is a low priority or the high priority, whether you want to answer it or don't want to answer it. So those all things actually are part of the exceptions, means something conditions which halts the normal execution. Okay, so of course we have discussed all these different conditions here. Now we shall look into it, what are the different types of exceptions we have it here. So this what we have it here are 7 different types of exceptions: reset exception, data abort exception, FIQ means fast interrupt request exception, interrupt request exception, prefetch abort exception, software interrupt exception, undefined exceptions. Okay, so these are the different types of exceptions you have, and these are the different types of processor modes you have, as you can see here. Okay, so this is basically if undefined exception happens, the processor will be in the undefined mode. See, whenever exception is raised, the processor switches to the different mode. Okay, by switching off the different mode, of course you have certain instructions. The switching of the mode has to be done because the processor will be in the different mode to handle the respective exceptions. That is what you can see it here. Whenever some undefined exception happens, so what are the different types of exceptions? It is listed here. So what is this reset exception? Whenever actually, let me write it here. First one, reset exception. Reset exception means something actually is power is on here. Okay, when you turn on, whenever actually system is turned on. Okay, when turned on, let me write it here. Whenever it is turned on, or something actually you press the reset button. Okay, at that time actually the reset exception occurs. Reset exception whenever occurs, the processor will go to the respective operating mode. As you can see here, this is the operating mode. What we say for this one is supervisor operating mode here. Okay, these are all different operating modes we have already discussed. So supervisor operating mode. So what do we do with the supervisor operating mode here? Of course, we will not go into that one, what we do in the supervisor operating mode. We shall just discuss actually different types of exceptions, how this different type of exception result in the switching of the different operating modes. Okay, now you have this reset exception. Next one is you have okay, what we do, whenever supervisor operating mode, what is the change that happens here? Maybe we have discussed this one, that is in the CPSR bit. In the CPSR register, the mode bits are there, the 5-bit mode bits. Okay, the 5-bit mode bits you have. So 0 to 4. So those 5 mode bits, that is changed. For example, if maybe the processor is in the some IRQ mode and the reset exception happens, the processor will switch from IRQ mode to the supervisor mode. When the supervisor mode is there, you have different mode the numbers, the mode bits you have particularly for the IRQ mode. Then you have a different mode bits for the supervisor mode. Similarly, you have the different the combination for the abort mode also. Okay, so those are changed here. This is I just wanted to stay here. These mode bits are changed in the CPSR, that is current program status register. Okay, so now, so first one, reset exception. What is the next exception that you have it here? The second exception that you have, it is data abort. This results whenever actually memory access violation happens, particularly data memory. Let me say data memory. So particularly whenever data memory access violations happen, okay, so data memory access violations happen, then this data memory exception is thrown. When can we have the data memory access violation? See, in this memory, whatever that is there, okay, in this memory there could be the instruction memory as well as the data memory. Instruction memory actually deals with the instruction. Whatever the instruction that is written, that instruction is stored in the memory. For example, if I add some instruction is there, add R1, R2, R3, etc. That instruction will be stored in the memory. That 32-bit code, the ARM hex code, 32-bit code that we have. So that will be stored in the memory. So that is what is instruction memory. Data memory means whatever the, for example, the load instruction. The load instruction, what do we say, LDR instruction. LDR instruction, something we write LDR R0 comma R1 hash of 4 bracket we put it. So in that memory location we have put some content. So the content that is there, that is data memory. Okay. So instruction, the instruction that is when put in the memory, the hexadecimal equivalent code, that is what we say instruction memory, and the content that is there, that is data memory. So whenever actually some data memory access violation happens, for example, the memory limitation could be there, or any other memory protection, of course, it is beyond the scope of a study. So maybe some memory management unit will be there, something actually you have MPU units, memory protection units. So you have protected this memory which you don't want to write it. So those kind of things, if you have done it and you want to write or you want to access those locations, at that time actually it throws an exception. Means you are not allowed to access these memory locations. At that time what happens, a data abort exception is thrown, and whenever data abort exception is thrown, the processor is in the abort mode. Similarly, you can just see this one, prefetch abort here. Prefetch abort is similar to the, let me write it here. This is with respect to reset exception, this is with respect to data abort exception, and let me actually have this one as prefetch abort. What is this prefetch abort? Prefetch abort is some instruction memory access violations. Same thing, in some instruction memory access violations if they happen. Okay. So instruction memory means whenever you want to fetch certain instruction, this is with respect, okay, prefetch. So whenever you want to fetch some instruction, after you fetch the instruction, try to fetch the instruction. At that time actually, if that instruction fetch is not allowed, it is also similar to this one only. If that memory is protected through the some protected region, what we say. So if it is protected, at that time you try to access those memory locations, then it will definitely throw an exception. It will tell you that you can't actually fetch the instruction from this memory because they are some protected, and it is not, it is just allowed to be, it is protected, means it is it is not at all allowed to be written or read also. At that time actually what happens, because there are some something like you have like a blueprint, okay, so maybe it is not allowed to be read and it is not allowed to be written, something like BIOS you have it. So those kind of things actually whenever you have, you are not allowed for the accessing the particular memory locations, and particularly memory locations where the instructions you have stored. Okay, instructions in a sense the hexadecimal equivalent of the instruction. Okay, so that time actually you can't access those locations. At that time instruction memory access violations happen, and then the prefetch abort exception is thrown, and then whenever prefetch abort exception is thrown, then your processor switches to the abort mode. Okay, so whenever similarly you have these two external interrupts, this is fast interrupt request FIQ, this is interrupt request. FIQ deals with a high priority interrupts, IRQ deals with a low priority interrupts. Okay, so high priority interrupts, what happens, FIQ and IRQ. So you can just observe here FIQ, of course whenever FIQ exception is thrown, then it is in the FIQ mode, the operating mode, the processor mode that is there in the CPSR, that will change to the corresponding 5 mode bits that you have. So the processor is in the FIQ mode. It is this IRQ, whenever IRQ exception is thrown, then the processor is in the IRQ mode. And whenever software interrupt exception is thrown, then the processor is in again supervisor mode. As you can just note down here, reset exception and the software interrupt exception, both these two exception, the processor is in the supervisor mode, that is SVC. Similarly, whenever undefined exception happens here, undefined exception, then the processor is in the undefined mode. Okay, there are some common modes also, as you can just observe here. Reset exception and the software interrupt exception, when both these two exceptions are thrown, the processor is in the supervisor mode here. Similarly, when the data abort exception and the prefetch abort exception is thrown here, the processor is in the abort mode. The processor is in the abort mode for both data abort as well as the prefetch abort exception. Well, you can just ask, sir, don't you think actually how will it differentiate? One thing what you have to understand is that these different processor operating modes are like the profiles that you keep it in your mobile. Silent profile, general profile. Whenever silent profile is there, what are the various things that that happen? Like maybe ringtone volume is reduced. Okay, so do not disturb profile, or something general profile, or vibrating profile. These different profiles actually your operating system adjust and the hardware adjusts according to the different profiles that you keep. So here also, one thing what you have to understand, data abort exception, prefetch abort exception, even though actually both are whenever both these two exceptions are thrown, it is in the common operating mode, that is abort mode. So one thing what you have to understand, how is it possible? Because data abort exception, the prefetch abort exception, they both never occur simultaneously. They both never occur simultaneously. It can never occur simultaneously. Okay, so that is what I was saying, it can never occur simultaneously. Why? Because see, data abort exception is related to the data fetching from the memory, prefetch abort is related to the instruction fetching from the memory. This is with respect to the data, means data, when you actually take the data, that is only comes, so you have the pipeline stage, one is fetching, another one is decoding, another one is executing. See, prefetching, after fetching, it actually goes, of course you have some pipeline registers here. Okay, so before actually it goes from fetch to decode, something is kept in the pipeline registers. Now here fetch, after fetching completes here, it has to go to the decoding. After decoding of the instruction means what instruction has to be done. Okay, then you understand the instruction that is done here. Fetch the instruction, take the instruction from the memory, understand what the instruction is, then execution. Here it completes the movement of the data from the registers to memory and the memory to the registers. So that can happen only when it is executing. Only when it is executing, then only you come to know what is happening here, isn't it? So that is, data actually is taken at this step only, execution step, only when you are already in the execution stage, where actually the PC would have incremented by 8 here. Here it is PC, isn't it? PC plus 4. So when it enters the decoding stage to understand this, what this fetching you are doing here, okay, at that time actually you are just instruction is being taken at this stage. Execution data is taken at execution stage. Okay, of course, let me not write at this stage here. Maybe better prefetch, after prefetch, because you are fetching the instruction, try to fetch the instruction maybe at the entrance of the decoding stage. Okay, just observe carefully here, at the entrance of the decoding stage, and this is almost at the end of the execution stage. Here the data abort can happen. Data abort can happen. Where can the prefetch abort can happen? Prefetch abort can happen at the entrance of the decoding stage. Here prefetch abort. Here prefetch abort can happen at the entrance of the decoding stage. So these two can never occur simultaneously. That is for sure. These two can, any of the instruction, if you take it, these two can never occur simultaneously. That is why sorry, these two can never occur simultaneously. The processor will definitely be in the, that's why one operating mode is there, so to handle both these two exceptions. Similarly, you just take care that reset exception and the software interrupt exception also, they both they occur in the one operating mode, that is supervisor operating mode or supervisor processor mode. Okay, so this is how actually means whenever any of these 7 exceptions, these are just handled by the 5 processor modes here. So any of this exception happens, so if the processor is in the IRQ processor mode, handling the IRQ exception, suddenly actually some FIQ interrupt is raised through the FIQ pin. Okay, of course you have different pins also, let us not go through details of that one. Okay, when you have your FIQ pin, you have the IRQ pin, you have the abort pin. Okay, so all those things, sorry, abort is, there's no pin, that is because of the instruction only. You have the FIQ pin and the IRQ pin. So if the IRQ pin, actually the processor is in the IRQ mode, suddenly through the FIQ pin another some high priority interrupt is raised through the FIQ pin. The processor understands that one, it just directly goes to the before it goes to the FIQ exception of FIQ mode, to handle the FIQ exception, the processor will switch from IRQ to the FIQ mode, because the FIQ is having the high priority. That we'll just look into it later, but now just understand that there are different operating modes to handle the different exceptions. Okay, so let us move to the other slide. Okay, this is with respect to the vector table. Okay, so as I said earlier, you have like different exceptions here. Can you see this one? This is reset exception, undefined instruction, software interrupt exception, and all these different exceptions. Of course, you have the short form what you write it here. Just observe this one. Each one has this vector table. Vector table, in a sense, it's like a address that is stored. The branching address. Where do you want to? Whenever some exception is raised, where do you want to switch? Exception handler. Okay, this is what we say, interrupt handler, same as the exception handler. Of course, you write many of the exception handlers here, but this is like the branching instruction. The branching instruction what you store for each exception. For example, the branching instruction for the reset exception, that is stored at 0x00. That is what you can see here. See the first memory address. As you can just see here, this is 32-bit address. This is 32-bit address. The maximum that you can have is FF, all 8 Fs from 8 zeros. So total is 2 power 32. Isn't it 32-bit? So total what is memory location, the memory mapping, if I just say this one, you have 4 GB. Okay, this is 4 GB. Now just observe here, for the branching instruction for the reset address, that is there in this starting 00004 zeros. Now for second vector table, that is there in, this is for the branching instruction, that is there in the of course branching to the undefined handler, branching to the reset handler. So branching instruction for the undefined instruction exception. Okay, similarly branching instruction for the software interrupt exception, that is there in the 0x08 address. It goes on like that way. Similarly for this one, prefetch abort exception, to handle the prefetch abort exception, you have the branching instruction for the prefetch abort exception. Whenever branching instruction to the prefetch abort exception means you are branching, where you are branching? You are branching to the prefetch abort handler. See what are these handlers? The handlers are kept in here. Of course, we will look into the next slide, you will come have a good picture. But one thing what you have to understand from this slide is that all the branching instruction for various exceptions, they are stored default, they are predefined addresses. These predefined addresses, what we call it as vector table, and predefined addresses for the different exceptions. For example, predefined address for the reset exception, where do you want to, the way means the branching to the reset handler, that instruction where do you have for the reset exception, that is there in 0x00 address. Whenever reset exception is encountered, you just actually take out the instruction from this 0x00. That is what you mean by this one. Got it? Whenever FIQ exception is raised, then take out the instruction, what is their instruction from this address. Whenever actually data abort exception is raised, take out the instruction from this address. That instruction will be there. What is that instruction? That is a branching instruction. Okay, let's take a look into that one later on, but understand here, whenever actually software interrupt exception is raised, what do you do? You take out that instruction from this 0x, this address, some instruction is there here that you execute. Okay, that is what it happens. Or because see, one instruction, only one instruction, all these are branching instructions. Okay, they are basically what you, of course branching instruction, load is also one kind of branching that is being done here. Now what you have to understand here is that, because we know that actually instruction, how much instruction is 32-bit here, isn't it? It is 32-bit instruction. 32-bit instruction means how much byte will be there? It is 4 byte, isn't it? 32-bit means 4 byte. So 32-bit means 4 byte when you have instruction, because the numeric that is finally machine code, hex code for any of the instruction in the ARM instruction set you have here is 32-bit. And one more thing, there is never actually, even though processor is in the thumb instruction set, all the exceptions and the interrupts, they are handled in ARM instruction set, ARM mode only. Okay, now instead of saying ARM mode, you have to say ARM state. Okay, kindly make that change. It is never mode, it is always state. Mode means operating modes, the processor modes you have, like SVC or the undefined, they are the modes. State, ARM state. Okay, It is never in the thumb state. Even though you are in the thumb state, some exception is raised or some interrupt is raised, the processor switches from thumb state to the ARM state. That is what you have to bear in the mind. So all these 4 bytes you have, that is basically your one instruction. See, that is what you have here. One instruction is stored in from 00 to 4. 4 to 8 again one instruction. The one instruction, that is basically the branching instruction to the branching instruction for the exception, undefined exception, and that is basically the branching instruction you have to branch to the undefined handler. Okay, handler is basically handing the exception. That is also stored here only. Okay, we will move to the next slide. Okay, and this is what, see, this is what I was saying there. See, if you have a code, okay, this is the memory map that you have here. All the code and data that is stored here. Okay, these are the interrupt handlers, and this is the vector table. Same thing has been written here. Of course, you have vector table, you have the reset vector, undefined vector, SVC vector, FIQ vector. Okay, so you have undefined vector, SVC vector, and the FIQ vector. Now, just observe this one, what happens. See here, this is what has been written here, 00 to 1C. Okay, this is what 00 to 1C. Okay, so you have a vector. Of course, you have some instruction here that we'll just look into it later. Now, you have reset vector, undefined vector, SVC vector, all those things. It is same as this one that you have it here, till here. Okay, whatever that I am writing here, it is same as this one. Fine. Next one, what you have, this is FIQ ISR, something reset code, SVC ISR, and this is what interrupt handler. Interrupt handler means, as I said earlier, it is same as the exception handler. Don't get confused. This is also exception handler. Interrupt handler, exception handler, they one and the same here. Interrupt is a special type of exception, that is for the FIQ and the IRQ interrupts. Now, this interrupt handlers, what you have, it could start from this memory location, it could end at this memory location. Of course, you have some code here. Can you see? This consists of set of addresses. This consists of set of memory addresses, and this consists of set of memory addresses. What we say ISR, ISR means what we call interrupt service routine. Okay, so ISR is basically interrupt service routine. This is important. So interrupt service routine. What is interrupt service routine? See, ARM is executing certain instruction. Okay, so any of the instruction, something let me say something add instruction, it is executing. Suddenly some FIQ interrupt is raised. That is, at the FIQ pin, some interrupt is raised. Means some high priority interrupt from the external device like UART device, okay, that raises an interrupt that sends a signal to the processor telling that I need some attention from you. At that time, what happens, it will actually, of course, it will finish the execution of this instruction. That you have to understand. Whenever the processor is interrupted by any of the exceptions or external events that we call it as interrupt, your processor stops, okay, sorry, processor completes the execution of the instruction, then it will not execute the next instruction. It will not execute the next instruction. Okay, what it does is that it jumps to the corresponding, okay, first okay, whenever actually, let me actually repeat here. So for example, let me say that as some add instruction is getting executed, it is still under the execution. Some FIQ exception is thrown. Why FIQ exception is thrown? Some external device like UART, okay, it has raised the FIQ, it has raised the request through the FIQ pin, okay, demanding immediate attention. At that time, actually FIQ exception is thrown here. When FIQ exception is thrown here, what processor does, it completes the execution of this instruction. After it completes the execution of this instruction, it will go back to this, it will go to this FIQ vector, because it knows that whenever actually whatever I receive the signal through the FIQ pin, I immediately, whatever the instruction I am doing, first complete that one, but I will not execute the next instruction I will not execute the next instruction. This is what you mean by the exception. Exception has disturbed the normal execution of the instruction, because normal execution of the instruction, maybe let me say something subtract, you are doing the next instruction. It has disturbed here. Now this instruction won't be executed, but immediately it will pick up, because FAQ exception has been raised by the UART device. This FAQ exception is taken here. Now immediately actually if you go for this address, what is the address whenever FAQ exception is there? You can just observe here, okay, FAQ exception 0x1c. So if you go to the 0x1c, some instruction branching to FAQ handler. Okay, so what happens? FAQ handler, you have some interrupt service routine. That is what you have, starting address of the interrupt service routine. It will from immediately it will here, it will jump to the starting address of the FAQ ASR. Maybe starting address is 0x something will be there here. Then final last address will be 0x here. Again it will return from here to this normal execution of the instruction. The next instruction, this will be taken. Okay, we'll discuss this one in very detail in the coming slides. But now what you have to understand here, the flow, how the flow happens means, let me repeat here. First what happens, some add instruction is getting executed. Now some UART device requests the attention of the processor through the FAQ pin. So the processor understands that some request has been raised by device through the FAQ pin. So what it does, it of course it completes execution of this add instruction, because it can't actually immediately stop there. Okay, it has to complete the execution of this add instruction, but it will not execute the execution of the next instruction. What it does is that it just immediately answers this FAQ request. Okay, that is fast interrupt request. So FAQ exception is thrown here. That FAQ exception, whenever it is thrown, we know that it will jump to this address. Okay, it will go to this address. It will go to this address and fetch this instruction. What this instruction will be there? This instruction will branch to the FAQ handler. From this instruction it will branch the FAQ handler. FAQ handler basically is interrupt service routine. Handler and interrupt service routine, sometimes it is also called as interrupt routine. It will actually branch the starting address of the FAQ ISR, and it will do whatever it has to do here. Interrupt service routine basically handles the exceptions. So what do you mean by handling the exception? Means what you have to do whenever any exception is raised. Okay, for example, something actually FAQ exception has been raised. So for this UART, it might have sent the data. I have to take the data. Okay, so that data has to be taken from then stored in the registers, and then something has to be done. Whatever the action that you want to do, for corresponding FAQ, what you want to do. Okay, that is what you service that interrupt. Whenever some interrupt has been raised, what I want to do, what are the actions that you have to do, that is there in interrupt service routine. That is what we say interrupt service. You service that interrupt. Whereas FAQ vector, what is stored in here is that just a branch instruction. It could be branch instruction or some load instruction, but load to the PC. Something, it is only one single instruction you have it here, where you are actually branching to the FAQ handler. Okay, that is what. See, for example, if IRQ exception is thrown, let me take another one. Maybe something SVC vector is shown here. You can just look at the arrow here. Maybe some just normal execution is happening. Something actually for SVC actually, what do we have here? Some reset. You just put on the power, turn on the power, or press the reset button. Whenever you press the reset button, immediately actually what kind of exception is thrown? SVC exception, that is reset exception. Sorry, I am very sorry. This is not SVC exception. You should never say SVC exception. This is basically what you have, reset exception. Okay, so reset exception is thrown here. Whenever some reset exception is thrown, what happens? It switches, it goes to the address. This is predefined. There is no way that you can change this one. It goes to this address, and it from this address it takes the instruction. That instruction actually what will branch to the SVC interrupt service routine or SVC interrupt handler. That is what you can see here, branch to SVC handler. It is same as that one. Handler is same as interrupt service routine. So again it will go there. Here you have single instructions. Here you have set of instructions. Okay, here you have single instruction just for the branching purpose. Here you have set of instructions, and from that instructions you are going to execute whatever the actions that need to be taken. Similarly, for the undefined also you can just observe here. Maybe something like okay. SVC, okay, reset, okay, this is fine. Now, similarly, actually, you have some do we have okay, so this is one correction I just making. Maybe this is software interrupt exception. Okay, of course reset initial code is written here. This is software, some software interrupt exception can happen here. So that is what SVC vector is there here. As you can just observe here, this is another reset vector. Okay, reset vector is there here. I am sorry, just make this correction. Reset vector is for the this one. Whenever reset exception is thrown, reset vector is here. Starting address is, this is for the some software interrupt. Okay, this you can just observe here. I just missed out this one, just make that correction. Whenever actually you have reset, of course it is in the SVC mode here. So SVC mode, but what is the SVC mode? Reset exception, the start vector table offset is this one. Okay, for a software interrupt exception, you have this one, that is 08, so you have this one. So SVC handler. Okay, just a small correction, nothing to worry here. So SVC vector, basically this is software interrupt exception. Whenever SW exception happens, so it switches to this SVC vector. From SVC vector it goes to this SVC ISR. SVC vector has only one instruction. SVC vector has set of instructions to handle the software interrupt exception. Okay, so similarly actually whenever reset exception is thrown, then the processor actually switch to this reset vector. It takes this jump instruction, that is branch instruction, and from here it branches to the this code, starting address of reset initialization code. Here set of instructions will be there to handle the reset exception, and then the reset exception is handled by this interrupt service routing. Okay, whatever that has to be done, it will be done by this set of instructions which are there in this interrupt service routing. We shall not look into this, what all different instructions we have to handle the different exceptions. That is beyond the scope of our study here. But one thing what you have to understand is that the exception just disturbs the normal execution of the normal flow of the execution of the instructions. Now that exception, whenever that is raised, so vector table, what do you have for the vector table? Vector table, you have certain predefined addresses. Those predefined addresses, they store the instructions, starting at branch instructions to the respective ISRs. Maybe let me write it here. So vector table consists of predefined addresses for the various exceptions. Okay, predefined address for various exceptions. Okay, in this each address, what do we have? The branching instructions to different branching instructions to, let me write ISRs. Okay, so branching instruction to respective ISRs. So respective ISRs. Okay, this is what you have it here. So branching instructions to respective ISRs. So this is what you have it here. So from that one it branches. Of course, this everything is there in this memory only. In this entire memory location you have it. Okay. So how is this done and all those things we shall look into the next video. Fine. Thank you.